Okay, continuing this problem, I realized I made a little bit of a mistake. And I just copied these constraints down. It just lets you know that this kind of stuff does happen. So if you look at it, these constraints were less than or equal to. So if you look at my constraint box, it was less than or equal to 40, and then less than or equal to 240 here. Okay, so that changes my feasible region. So I'm shading below the green and the blue line. To find out where I'm shading here, so C has to be greater than or equal to 2R. So you pick a point above or below. So if I pick a point, say right here, this is the point 10, 2, okay, and I'm looking at this, the C value is 10. Is that more than 2 times the R value? Yeah. So I'm shading below this line. If I picked a point like 5, 5, and I looked at this equation right here, 5 is not greater than 2 times 5. So I know I'm shading below the red line. So below the red line, below the green, below the blue. So this feasible region is all right here. Okay. And so if I look at my vertices are right here at 0, 0, where the blue and the red line intersect, where the green and the blue line intersect, and right here. So I've got 4 vertices. My vertices are 0, 0. And then if it looks like, what is it, 16, 0. And then I figure out where does the red line intersect with the blue line. So the red and the blue line is what, 2, 4, and 10. So, and 2 should be 2, 4, and less than or equal to 40. Okay, so where does the blue and the red line intersect? So go to my calculator, and if I look at that menu, algebra, solve system, 2 equations, 2 variables. My variables are C and R, and so the equations are 2C plus 4R equal 40. And the next equation was C equal to R. So C equal to R. And that comes back with 10, 5. So I know this point right here is 10, 5. And then where do the green and the blue lines intersect? So go back to my calculator. I'm just going to reuse that calculation. So I just need to re-input this one. So I've got the so 2C plus 4R equal 40. The next one will be what, 15C plus 15R equal 240. Where do those lines intersect? At 12, 4. So 12, 4 and 16, 0, 0, 16, 0, 12, 4, and then 10, 15. Now it's just a matter of plugging those in. I'm trying to minimize my cost, and my cost was what? That's the revenue, maximize the revenue, 5C plus 7R. So the revenue is 5C plus 7R. So the revenue at 0, 0 is going to be 0. The revenue at 16, 0 is 5 times 16, which is 80. The revenue at 12, 4 is 5 times 12 plus 7 times 4, which is 60, plus 28, which is 88. And the revenue at 10, 15 is going to be 5 times 10 plus 7 times 15, which is 50 plus 105, which is 155. Okay. And then, sorry, as I double check this, when I solved this, I got 10.5. That makes a world of difference. 10.5, not 10.15. So this point is 10.5. So when I look at this calculation, it's 10. Let's just redo this one. So the revenue at 10.5 is 5 times 10 plus 7 times 5. That's 50 plus 35, which is 85. Sorry for all the confusion there. And this is my maximum value. So again, this one was a tougher one with a challenge, mainly that constraint about the number of chocolate chips being double the raisins. So what was the question? The question again was, how many of each types of cookie to maximize the amount of money for charity? So it looks like we need to do 12-4. So 12 chocolate chips and 4 raisin to maximize the revenue. And the maximum revenue was $88 in this case. Okay, that's it. So that was a tough one. You're probably not going to see something that tough on the test, but it just pushes you to know that you can get the concepts.